Today we want to go through your hands-on lab pack and examine the specimen and inventory the contents, talk about safety procedures, and identify some of the physical properties that you'll need to take care of as you name your mineral and rock specimen. So take a second to grab your lab pack kit, and then let's open it up and have a look at what's inside. In inventorying the contents, you have a content list which has numbered items and a description of each one of those. So you want to make sure everything is in place. Obviously, safety is our number one concern, and so I will advise you to wear the goggles that are provided and the nitrile gloves. It's particularly whenever you're using the hydrochloric acid, which is a weak acid. It's 3% hydrochloric, but yet it can burn your skin and definitely would be an eye hazard. So always be careful with the acid and wear your safety goggles and gloves. When you look at the actual specimen, you're going to see everything in small bags that are inside one bag that's labeled a rock set. Now this is a little bit misleading. It's not only the rocks, but it also contains your minerals. The minerals will be the first thing that we work with, and they're labeled individually inside mineral bag 1, 2, and 3. So that's what we'll be working with today. Also in your kit are some testing tools, namely a glass plate, a streak plate, a magnet, an iron nail, a copper wire, and a folding magnifier. And we'll take a look at how to use each one of those as we go along. Now, there's several physical properties that are important for you to test for using these tools that we just looked at. The number one property that we want to talk about first is color, because color is the least reliable of all of the physical properties. Just a few rogue atoms in the mineral chemistry can produce drastic differences in color. So you should never let color be the final determining factor in naming your mineral. There's just too much variation. Now there are a couple of exceptions to that, and your lab manual notes that olivine in particular is one whose color can be relied on. But for the most part, don't rely on color. Rely on these other properties that we are about to take a look at. First among the physical properties that you'll be testing for is hardness. Now hardness is the resistance that a mineral has to abrasion, and we use a very simple test for this. It's called the scratch test or the hardness test, using the glass plate that's provided in your kit. Now, you should never hold this glass plate in your hand to use it. Always lay it down on the table, put your fingers on top of it in the case that it breaks when you're performing the test. In order to perform the test, you'll take your unknown sample and you will try to scratch the glass plate with it. Now the glass plate has got a hardness of about 5.5 on Mohs scale, so it's about midway in the Mohs scale of hardness. If your mineral sample scratches the glass, then you've determined that your mineral is harder than 5.5 on Mohs scale. The other items in your kit that can be used to test for hardness are all softer than 5.5 on Mohs scale. The nail is at 5 or 4.5 on Mohs scale. The piece of copper is about 3, and finally your fingernail is about 2.5 on Mohs scale. So for a mineral sample that does not scratch the glass plate, you can try to narrow its hardness down by using the nail, the copper wire, or your fingernail. Keeping in mind that there are a couple of issues that can go on during the hardness test. Number one, if your mineral is softer than the glass plate, it's possible for you to leave a powder of your mineral on the glass plate. So you should try to wipe it away with your finger or use your fingernail to see if you can feel the scratch that you might have left on the glass plate. Examine that very closely before you determine the hardness. Another physical property that you will be looking at is the property of cleavage. Now cleavage is the tendency of a mineral to break along a preferred plane of weakness that's set up by the bonding types and the atoms that are in the molecular formula. Not all minerals have cleavage. Some minerals, they'll still break, but they simply break along an uneven surface that we call fracture. So your mineral will either have cleavage or fracture. if you can identify cleavage surfaces, they will appear as flat, reflective surfaces. They'll be bright and shiny, and very often they occur in parallel sets, so that they may, you may have a type of cleavage that we call cubic cleavage, where you have 3 pairs of parallel sides that form a cube. Or you may have a mineral that has rhombohedral cleavage, where you have 3 pairs that are parallel to one another, but they're not at 90 degrees. They're more in the shape of a geometric rhomb. Other minerals only have 2 planes of cleavage, and some minerals, such as the micas, only have 1 plane of cleavage. But what you're looking for in general is a flat, reflective surface that may occur in parallel or in pairs. Now, one caution for cleavage is that many minerals occur in their natural crystal form. Quartz is a good example of that. Quartz is hexagonal, and it tapers off to a point. We call it a hexagonal prism. And these surfaces are flat, and they will reflect light quite well, but they're not cleavage surfaces. Technically, quartz does not have cleavage. It will break and it will fracture, and it will leave an uneven, rough surface on that fracture surface, but it's not cleavage. So take a look at this quartz crystal, and you can see these hexagonal sides. And let's compare that with a mineral that has rhombohedral cleavage. 3 sets of parallel sides not at 90 degrees. And we can add a third one to the mix, galena, which has 3 pairs of sides at right angles. And you can see the stair-step nature of this one, that it's not broken along perfectly flat surfaces, but rather a stair-step type surface with surfaces that are parallel to one another. So if your mineral exhibits these flat, smooth, shiny surfaces, it may be cleavage, and that may be quite helpful to you in identifying it. Keep in mind, though, that it could be a crystal face rather than a cleavage surface. A third property that we'll consider is the property of luster. This is the appearance of a mineral in reflected light. We're going to divide our minerals into 2 basic groups, those that have a metallic luster or submetallic luster, and those that have a non-metallic luster. Now, the metallic luster is quite easy to recognize. It looks like metal. It's bright and shiny, and that's because it has metallic atoms in it. It may also have a high specific gravity, so it feels quite heavy in your hand. A submetallic luster, on the other hand, may be oxidized. It might have iron in it or copper that has gone through a reaction with atmospheric oxygen and changed the luster from a bright and shiny one to a dull or oxidized submetallic luster. So we'll be making some observations about luster. I will compare that with something that's often confusing for beginning students, a non-metallic luster. It's quite bright and shiny, but it doesn't look like metal. It looks like glass, which we call a vitreous luster, or maybe it looks like plastic. So just because it's shiny doesn't mean it has a metallic luster. It needs to look like metal and probably even feel like metal as far as its density goes. The last property we'll consider is a property called streak. To test for streak, you're going to use one other tool that's in your set, the streak plate. This is a piece of white, unglazed porcelain. And the test works very similar to the hardness test. You're going to scratch or rub your mineral across the surface of the streak plate and observe the color that's left behind. The color of the streak is most important for your metallic minerals. Other non-metallic minerals may leave a streak, but it's not as diagnostic as it is for metallic minerals. Now, one more caution similar to the glass plate caution. If your mineral is harder than the streak plate, you can scratch the streak plate and leave a powder of white porcelain tile behind, and it will look like a white streak. So again, see if you can wipe the streak away and pay close attention to what you're doing with this test. Now finally, I want to say that as you open up these bags, you're going to see that they've bounced around in shipment, and you've maybe carried them from place to place, and there's been some abrasion of the minerals on each other inside the bag. And so and that makes identification a little more difficult. So I would recommend that you wash these minerals just in a little bit of tap water to wash the dust off of them and try to get to a fresh, unweathered surface. These will be the best surfaces for you to use and try out these tests on. So just rinse them a little bit, maybe use an old toothbrush or something to clean them up, and then set them aside and let them get good and dry before you begin your testing process. I also want to show you how to use the hand lens. Proper use of the hand lens would be to hold it very close to your eye, right up next to your eye, and then move the sample up towards the hand lens until it's in focus. So hand lens goes right up against your eye, and the sample moves in right tight and close to it. Well, have fun with your minerals.